Thank you. All right, so that was the glass. You know, after that, everything else is anticlimactic, right? Yeah, we have toys. Yeah, we have toys. One of the things I was telling you about, this guy has been a notorious pain in the butt for me to get to work. There are quarters when I can make it sing like crazy, and then quarters where I realize I'm using the wrong end of the stick. Well, we'll give it a shot. It's a standard, you know, sort of copper bowl, nothing real fancy to it. If I bang it, just drive it in a completely arbitrary way. It rings for an awfully long time. Okay? Very high quality resonance. Now I'm going to bang it again, and what I want you to do is pay real particular attention to that instant when I bang it. Okay? When I smack it, you're going to hear the stick, you're going to hear a rasp, and then you're going to hear the music sort of kick in. I don't know if you noticed that sort of rasp that was in there. Okay? What is that? I'm driving it in an incredibly arbitrary manner. I'm exciting the bowl over a range of frequencies. But the only frequencies that persist, okay, the only frequencies for which you get a long living wave, you know, a slow to damp out wave, are the frequencies with large amplitudes, the resonant frequencies. So when I bang this, the non-musical part dies, and the musical part persists for a long time, which is kind of cool. Okay? The harder part, or the one that I have, what's that? Yeah.
Can you put the bowl in the microphone?
Everything's disconnected now. I was thinking the same thing, but also the microphone is directional. It's the long tube is actually a filter, so I don't know. I've never actually used it for that purpose. I don't know how it will work. The other way to excite this is to actually run the stick around the rim of the bowl, kind of like, you know, wetting your finger and running it around a champagne glass. I have only slightly better luck with the bowl than I have with champagne glasses. That's because I usually drink whiskey. It's actually a little lower than the last time. It's a different resonant mode. When I bang it from the side, the dominant mode is that sort of bell mode, kind of high pitch. When I rubbed it, I could actually hear, I don't know, what we would call it, subharmonic? Maybe the fundamental. Maybe when I bang it, I excite a harmonic. That's cool. I don't think I've noticed that low harmonic before. The rasp, when I was running the stick around, you guys won't know it from where you are, but the problem is the amplitude of the bowl is so large it's causing the stick to bounce on it. When the amplitude is relatively small, I can move this smoothly, but as soon as the amplitude starts to grow, it causes the stick to begin to bounce. About there, the amplitude is so significant that the stick bounces. Of course, about half the time I do this demo, I walk in thinking, oh, it's the felt that I rub. No, the felt is a big damper. The felt, I think, is to keep your fingers from going numb when you rub the bowl. Okay? So that's one of the demos we've got. The other one, let's see, musical tubes. I actually saw these in a kid's store somewhere the other day. And I was going to buy a bunch. And my wife just looked at me and said, don't you think we've invested enough in musical instruments? Of course, it was the day after we bought my son's violin. So, like, yeah, maybe we have. These tubes, what do we have? We have tubes of varying length. I'm going to try very quickly to to order them sort of in some semblance of length. So I've got, you may or may not be able to see it from there, but long tube to short tube. Let me try standing it on the ends. That's sort of maybe not a bad exercise. The shape will actually probably look familiar to anybody who has seen an organ. Because how do organs work? Well, they blow air through long pipes. The pipes are cut in proportion to the resonant frequency. And the resonant frequencies that you want your organ to make sound at are the same resonant frequencies that these are tuned to. Right, maybe an octave or two higher or lower, but these are marked C, D, E, F, G, A, B, C. They're marked with the same musical notes that an organ would have. Okay? Just for the record, I actually did some calculations the other day. It turns out that for most musical notes, at least the natural notes, not sharp, not flat, most of them, if I remember correctly, are about 12% higher than the preceding note. So most of these tubes are about 12% longer than the preceding tube. Every once in a while you have something thrown off a little bit. Some of the notes are only 6%, a lot higher, go figure. But long ago somebody determined that that makes music that we recognize. Okay? So of course, sound resonance in particular, the resonant frequency is proportional to length. So the long tubes resonate at lower frequencies. Oops. Let me move that up. Bad. We've got a few hours. Any deadhead, what I'm talking about. All right. All right. Well, of course, boundary conditions play a big role, right? For an open or let's say like boundary conditions. The fundamental in this case is going to be V sound over 2L. Okay. What if I have mixed boundary conditions? For mixed boundary conditions, it's going to be V sound over 4L. Okay? The resonant frequency is going to drop by a factor of 2. So let me find a tube that's got a nice, easy to memorize sound to it. I think E will work. I like A better. So this has got like boundary conditions. I can see you. Let me change that. I've got a cap here at the end. Put a cap on one end and bang it again. Simple but cool. Notice they both sound like A notes if you're a musician. If you're not, they just sound like notes. But the difference between a low A and a higher A, basically each octave is a doubling in frequency. So I think middle A is like 440 hertz. The next octave up for A would be 880 hertz. So this is, let's say, I don't know, maybe a middle A. If I put the cap on, it drops to the A right below. So you can actually double the octaves in an organ by removing stops from the bottom and that sort of thing. I've got a friend, actually, an engineer who's really into organs that I talked to on the radio. We had this real long conversation one morning. I was stuck in traffic on the 405. But it was all about organs and resonance in the tubes and boundary conditions. And since he's an RF engineer, somehow it all got mapped back onto antennas and impedances and stuff that some of you will learn in a quarter or two. It was kind of cool.